Today we have two parts of the lesson. First of all is positive and negative definite quadratics, which will go very, very quickly in less than 10 minutes, and then the remainder will be finding quadratic functions from the graphs. So yesterday we started on that. Yesterday we looked at finding all quadratic functions given two roots. Today we'll be given two roots or other piece of information, and instead of finding all quadratic functions, we'll find the one specific one. Alright, but first, positive and negative definite. Now, Miss Chris and I are racking our brains, and we can't think of any specific purpose for this, except that it helps us talk about quadratics. So when you guys are chatting about quadratics at lunch, it gives you an extra piece of, because I know you do, it gives you an extra piece of terminology to use. Essentially, if our discriminant is less than 0, and you should all remember, most of you got this quite well on the test, if the discriminant is less than 0, and discriminant being b squared take 4ac, then the graph will do one of two things in relation to the x-axis. If that line is our x-axis, it will either do this, lovely arrows, or it will do this. Alright? So if the discriminant is less than 0, it will not touch it. It'll miss it. Now, what differentiates between these two, except that one's arrow is slightly worse? How can we tell the difference just by looking at the quadratic function? Yeah, good. The leading coefficient, or the number in front of the x squared, will be negative for this one, and will be positive for this. So if you have ax squared plus bx plus c, come in, Stangens.
You got Reuben Cannon in here?
No.
Have you got Reuben Cannon coming up soon? No?
This is your 11, no?
Yeah, no. Yeah.
Who's Reuben?
It says but, I know it's BDD, not BGD.
Right, wrong button.
Thank you, sorry.
No worries. Okay, so we can call a quadratic positive definite if it has two things. If its discriminant is less than 0, we know it doesn't touch. If its leading coefficient, that is a, is positive, it's positive definite. So our definition of the two is that a quadratic is positive definite if the discriminant is greater than 0 and a is greater than 0, giving you a smiley face above the x-axis. It's negative definite if the discriminant is, I've got those the wrong way around, less than 0. Less than 0. My apologies, I was saying it right, reading it wrong. The discriminant needs to be less than 0. Alright. So a common question where we'd use this is this example here. Show that x squared plus root 2x plus 12 is greater than 0 for all x. Essentially what that's saying is that regardless of the value of x, that quadratic will never return a negative y value. And we could, I guess, show it by graphing it. That'd be one way to show it visibly. But to show it mathematically, we need to calculate two things. First of all, the discriminant, and we need to state the leading coefficient. Leading coefficient is easy enough, it's 1. So it's greater than 0. Now we need to do the discriminant. So, discriminant is equal to b squared, so root 2 all squared, minus 4 lots of a, which is 1, lots of c, which is 12. Equals 4 minus 48. Root 2 squared is not 4. Now you've got to tell me these things. Root 2 squared is 2, leading to minus 46. Alright. So, we can say therefore the discriminant is less than 0 and a is greater than 0. We can even state, if we wanted to, that a equals 1. The quadratic is positive definite. Alright. Now, I'm not going to set you practice questions for those. I do suggest you do some before the test to remind you how to do them. But given what you really need to do is calculate the discriminant and state the leading coefficient, I'm confident from the last test you'll be able to do that. Fair enough? Alright, moving on then. Can you write, well, that, I guess. Determining the quadratic from a graph. And there are 3 forms of quadratic. Now, I guess at this stage it's useful to remind ourselves that alpha and beta are the roots. Yeah? And that h and k form a vertex at hk. Now, I heard that. General rule of finding quadratic functions are, depending on the information you're given, go for one of these 2 forms and find either alpha and beta first or h and k first. And then you'll be given a third piece of information, usually the y-intercept or another point on the line you can use to find a. So in last lesson we found quadratic functions based on the roots, 2 plus or minus 3i, or 2 plus or minus root 4, root 2. Either way, you're given the 2 roots, and you could find that, but with the a up the front. Those 2 pieces of information give you the roots. The third piece of information from the graph, you'll need to substitute to find a. Okay? Similarly here, if the vertex is given, it'll either be given as a turning point halfway through the line, or it'll be stated that the quadratic touches the x-axis, so if it touches, that is the turning point. Then you'll know h and k, and you substitute a third piece of information to find a. For when we're talking in pieces of information, turning points counts as 2, axis intercepts counts as 1. Right. Now, can you draw 2? Not sure from there. 2 axes. And label them, please. And then when you've drawn those 2, give your best attempt at a function that passes through those points I've given you. And I'll try, but you know with this pen on the board I'm messy. Oh wow. No. Better. Yay. An interesting exercise we'd go into if we had time is to see if you could draw a different quadratic that still satisfies those 3 points. And you'd find it was actually very difficult to draw a quadratic anything other than about the shape that I've got. However, if I removed one of those points, you'd be able to draw infinite quadratics through the remaining points. So if I removed the -2 requirement, you could put many, many quadratics through those. If I removed the 3 and didn't tell you what the other one was, you could put many, many quadratics through these two. For example, you'd have another coming down there, there, and up. Similarly, if I just told you the turning point, you could of course have infinite quadratics. But since you've been given 3 pieces of information, we've essentially nailed a quadratic. It has to be 1. Alright? Now, if we want to find the quadratic function from the left, which form might we be going for? Axis intercept, yes. So, our first line, I like writing down the form that we're going to use. Y equals A, x take alpha, x take beta. Now our next line is substituting alpha and beta. Remember, we leave A till last for in both cases. So our alpha and beta are x take 1 and x take 3. Then we're going to sub in the point 0 minus 2. Meaning that when x equals 0, y equals minus 2. And that's come from our intercept here. Alright, so y equals minus 2 when x is equal to 0. A bracket 0 take 1. 0 take 3. Okay. Now, that's a nice algebraic way to find it. What is entirely possible is that the question will ask you to state it in the form of ax squared plus bx plus c in general form. That's quite a usual question in a test, which means you would need to expand out. Alright, expand, collect like terms, have it written nicely in the form ax squared plus bx plus c. Now, I'm going to show you a way of using technology to do this. I think that's relatively easy. It seems to make sense. But let's say you have a mental blank there, or you want to check your answers. You can do it using technology. So grab your calculators out. And enter stat mode. I think you'll have been playing this with one of the other classes. Yeah? Now, really, you have 3 points, don't you, on that graph. You have the point, if we treat list 1 as x and list 2 as y, we have the point 0 And then in list 2, our corresponding point will be -2, if I can get across there. Alright, so that is x equals 0, y equals -2. That's representing this axis intercept here, the y-axis intercept. Our next one, x will equal 1 and y will equal 0. Alright, now note 3 pieces of information that have been put into our stat mode. So if we have 3 distinct points, we should be able to get a quadratic. Now, you can press across. Where's mine? Oh, enter. Click graph. Have you used this graphing mode before? In the other maths? Yeah? So set, you want scatter, list 1, list 2, which is excellent. And then graph it. And the graph will plot the 3 points. Okay. Now, you can tell the calculator to calculate a quadratic, which is what, F4, and you'll have your A, B, and C. -2/3, 2 2/3, -2, which is what you would get if you expanded out our form below. Okay? And r squared of 1, what does that mean from your other maths? Yeah, you are hitting every point. It's perfect. Your correlation is perfect. Okay. Now, that technology solution doesn't work when we have this second sort of graph. So consider the graph on the right. The reason it doesn't work is because our calculator can't handle us using this point twice. We can't put that in there twice. It doesn't give the calculator any extra piece of information. Because when we enter a piece of information in the calculator, it just assumes the line passes through it at some point. It can't tell whether it's turning at it or not. Alright. Which form would we use for this then? The other one, vertex form. So once again, similar steps before, we write the form y equals a bracket x take h all squared plus k. We leave a till last, we substitute in h and k. And note the sign change. Then sub in the point 0, 1.5. Leading us to 1.5 equals a lots of 0 plus 2 all squared minus 3. And once again, if we were asked for an answer in general form, we would expand and simplify. Now we can check this on our calculator by typing that into our calculator and finding the turning point, so finding the minimum. And the minimum will come out as -2, -3, or we can check by typing in there and finding the y-axis intercept. Yeah. So use technology to check these. Lastly, we can be given it in word form. So it has an axis of symmetry at 1, cuts the x-axis at -1, and passes through 2, 3. Alright, so based on that, we know that it will cut at -1. We'll pass through the point 2, 3. And has an axis of symmetry of 1. Let's call that 1. Now we only have 2 points. And we know that this, 2, 3, isn't a turning point, so we can't make it turn there. How can we find another point? Have we got enough information to give ourselves another point?
Yeah,
How?
because the axis of symmetry is the midpoint between the two x.
Good. Axis of symmetry is the midpoint between the two x intercepts. So -1, the distance between -1 and the axis of symmetry is 2. Therefore, the other intercept must be 2 on the other side. Yeah? So we need a distance of 2 either way. Alright, you can think about this visually. I like it visually, or you can think about it algebraically. Visually, the distance between there and there is 2. Okay? So the next intercept must also be 2 over. At 3. Yeah? Because 1 plus 2 is 3. The other way to think about it is using your midpoint formula. If we call this midpoint here, say, P, we know that -1 plus P over 2 is equal to the midpoint, which is 1. A middle of the, the axis of symmetry, or the midpoint, which is 1. Okay? That's like using half the midpoint formula when you're just looking at the x values. So instead of doing x1 plus x2 over 2, comma, y1 plus y2 over 2, you're just looking at the x values, because here we're only considering the x. So that's like x1 plus x2 over 2 equals the midpoint. And we know the midpoint. And then we solve, so -1 plus p equals 2, p equals 3. Come in, Tessa. Sure.
Are they all right? Just as long as
Not really.
Okay.
This will take 30 seconds from here.
Yeah, that's okay.
Alright, no, you can stay and watch, but no. Alright. So, now we have the 2 pieces of information we need. Or rather, 3 we need. We have our intercepts and a turning point. And a point on the line. Not the turning point. So because we have the intercepts, we're going with this form here. Y equals A. X take alpha. X take beta. And are you guys comfortable what to do with from here? Sub in alpha and beta, then sub in that final point to find A, and you're set. Alright. If you're all happy with that, you can then go on to the exercises set for today, which are in our plan, which was page 59. What exactly did I set? Who has the plan in front of them? Because I don't.
1K.2, 712 seconds.
Yeah, that's the positive negative definite.
Yeah.
And then this is question 1 seconds. Q1 seconds 2, 3, 4, and 5. Alrighty.